This video will cover the Flow Loop Trainer Capstone project for the Instrumentation program at the Oklahoma State University Institute of Technology. This capstone was done by team members Matt Hardin, Anthony Billy, Tanner Jackson, and Lane Cypert, and it was done for the spring semester of 2018. This trainer has 4 tanks totaling almost 600 gallons of capacity. The tanks are connected by a pair of independent lines of flow. Each line is driven by one 3-phase centrifugal pump. Flow in each line originates from one supply tank. This can be measured by Coriolis meters on each line and also diverted to any one of the other 3 tanks along those lines through the use of pneumatically actuated 3-way valves. The trainer is controlled through a touchscreen HMI that's installed in the trainer cabinet. It allows for touchscreen inputs as well as the reading of sensor values and the status of valves and pumps. This is the valve screen. The top row represents the solenoids that control the pneumatically actuated 3-way valves. The 3 buttons on the left are used to control electrical actuators for 3 ball valves that are on the trainer. 2 of those valves act for drains for tanks 2 and 3, while the third one can be used to connect the 2 lines together or isolate them. The center slider sets the position of a pneumatic throttling valve that is also on the trainer. From this screen, the speeds of the 3-phase pumps can be controlled. These 2 pumps are controlled by a pair of variable frequency drives. The single-phase pump, which returns water to the holding tank, can also be activated from here. This last screen displays the values from all the sensors on the trainer. The top 2 on the left are for the Coriolis meters. They display flow rates in gallons per minute unless the meters have been otherwise calibrated. The 4 on the top right display the fill level of each tank in inches. These values are taken from ultrasonic sensors that have been mounted at the top of each tank. On the bottom left are 2 differential pressure sensors. These measure the pressure inside the lines as compared with the atmosphere outside them. The last one is the reading from the 1,000 pound capacity drum scale, which is underneath tank 2. All of these values are provided with the trainer PLC through a total of 9 4 to 20 milliamp current loops, although the Coriolis meters are capable of using Modbus. This is a view of the interior of the control cabinet. To the far left you can see the HMI, which is mounted inside the open door. The HMI communicates with the PLC through an RS-232 connection. Up in the top left corner of the cabinet itself is an air regulator which manages the air supply to the pneumatic components of the trainer. The trainer's pneumatic components work best when the regulator is set to 60 psi. Directly below it is a current-to-air transducer which takes a 4 to 20 milliamp signal and converts it to a 3 to 15 psi signal for the pneumatic throttling valve. To the right are the variable frequency drives which operate the 2 pumps that run each flow line. The trainer PLC is located below the VFDs next to the DC power supply. The control relays on the bottom left are used to actuate the electrical valve actuators as well as the single-phase return line pump. This PLC is part of the CLICK product line from AutomationDirect. The main CPU is on the far left. It has several discrete inputs and outputs and also features a pair of analog inputs and analog outputs. These would not have been nearly enough for the number of sensors on the trainer, so 2 analog input expansion modules were added to the PLC. Each of these modules has 4 channels for 4 additional sensors. The first expansion module has the 2 Coriolis meters as well as the differential pressure cells wired to it. The second module handles all 4 of the ultrasonic level sensors. With 8 out of the 9 current loops connected to the expansion modules, the drum scale is the only one left that needed to be wired, and it was connected directly to one of the integrated analog inputs of the CPU. The next expansion module is a discrete syncing DC output. This is used to activate the control relays which switch the positions of the valve actuators and also activate the return pump. It may also be used for additional outputs in the future if more are installed. Now the fourth module is a relay output card. This was selected because the solenoids which switch the air to the pneumatic valves operate on 120 volt AC. This module was selected because it would substantially simplify the cabinet wiring by eliminating 5 extra relays that would have had to be installed otherwise. On the far right, the final module is an AC input card. This is able to provide the PLC with confirmation on the positions of each of the electrical valve actuators. The coils on all 6 of these relays are powered by the 24 volts of DC supply. Power to the coils can be interrupted by pressing the emergency stop button, which is mounted on the cabinet door. Doing so will remove all power from the three-phase pumps and the single-phase drain pump, and will also force all three of the electrically actuated valves to move to their closed positions, regardless of the controller output states. Here, the switching of two of the pneumatic valves and the response of the drum scale to the increased water level in this tank is just briefly demonstrated.
Alright, we'll install it.
This has been an overview of the Team 1 Capstone project at OSUIT in Okmulgee, Oklahoma for the spring semester of 2018. Thank you for watching.